Okay, today we're going to be learning about the quadratic formula. It's going to be our last way that we can use to solve a quadratic. We learned how to solve a quadratic by taking square roots. We learned how to solve a quadratic by factoring. And we learned how to solve a quadratic by completing the square. Now, on all three of those that we've learned, they only work in certain situations. They only work some of the time. Quadratic formula will work all of the times, but it is a very large formula, so it is kind of intimidating. So that is the quadratic formula. It will solve the quadratic every time, but it is a big formula, so it takes a little getting used to working with. But where it is a formula, it's just plugging in numbers and simplifying. All we have to do basically is plug and chug. So our goal today is not only to be able to find the solutions, we also want to find the types of solutions that would occur. There's going to be 3 different types. So we're going to start with being able to find the types of solutions, and then we're going to learn how to solve using the quadratic formula. Now this is a big formula, and you do have to have it memorized eventually. So you'll notice I wrote row, row, row your boat next to it. Usually a good way to help memorize large quantities of information is to put it to music. So a lot of teachers do Pop Goes the Weasel, but I can never remember the melody for Pop Goes the Weasel. I don't know why, it doesn't stick in my head. But I always remember row, row, row your boat. Yes. So, I will only do this once for each class, so don't ask me to do it a second time. This is how I remember the quadratic formula. It's to row, row, row your boat. Oh, now I have Pop Goes the Weasel stuck in my head. Okay, there we go. So I ignore the x equals and I start at the negative b. Negative b plus or minus square root of b squared minus 4ac all over 2a. Yeah. Amazing. I should quit teaching and go be a pop star.
In my opinion. Actually, no, you shouldn't, because then I'll fail.
Okay, so that can help you remember by putting it to music. If hearing it once didn't help you, it is now recorded, so go listen to it on YouTube.
Blackmail.
It's only blackmail if I sucked. Okay. So when we solve a quadratic, we have 3 possible ways that this could happen. Solving a quadratic could have 3 situations occur. So let's look at them as a graph. Remember, a quadratic, when we graph it, looks like a parabola. So we want to see the 3 different ways we could graph our parabola. We could, that's kind of a weird word, parabola. Okay. We could have a parabola that looks like this. And when we solve a quadratic, remember, we're solving for where it crosses the x-axis. We're finding the x-intercepts. Or they may also be called roots or zeros. It has 3 different names. So it may cross through the x-axis 2 times. The second possibility is maybe our parabola just barely touches the x-axis, and it only hits it 1 time. Or, the last possibility is maybe it doesn't hit the x-axis at all. So with those 3 possibilities, we have different names for those 3 options. The first one is we get 2 answers. And since we get actual answers, we call them real solutions. So 2 real solutions. So our first possibility is that we have 2 real solutions. Okay, so for the first possibility is we get 2 answers, and that's what we've been working with for the most part so far. So far, we've been getting 2 answers every time. So 2 real solutions. And you'll see in 1 second why we use the word real. Okay? Here we have 1 real solution. It only crossed once. So what do you think the last one would be? Okay. No real solutions, which is technically correct, but we also have a second name for it. So instead of saying no real solutions, what we say when this situation occurs is 2 imaginary solutions. Studying just this picture started a whole entirely new branch of mathematics. So trying to figure out what was going on with this and why there were no actual answers started solutions. Oh, and I keep pluralizing this. This is 1 real solution. There's only 1. It wouldn't be plural. So what if we don't have the picture though? We've been working with the equations for the most part. We have a formula. So what if we start with a formula and not a picture? We want to know what can we use to still figure out whether we have 2 real, 1 real, or 2 imaginary. So we use just a certain part of the quadratic formula called the discriminant. This is what was under the square root. We call it the discriminant. And this will tell us whether we have 2 real solutions, 1 real solution, or 2 imaginary. If we don't have the picture, then it can give us the information we need. If we have the picture, we could just look at the picture and tell. If we don't have the picture, we need to use what's called the discriminant. So we had our 3 possibilities. We had 2 real solutions. Oops. We had 1 real solution. We had 2 imaginary solutions. Give me 1 second. Okay.
Taylor Denton.
Yep. Okay, so there were our 3 possibilities. We need to know what about this discriminant is going to tell us which possibility it is. So we have b squared minus 4ac. If b squared minus 4ac is greater than 0, that's a fancy math way of saying if it's positive. Okay, if our answer is positive, we have 2 real solutions. Anytime we figure out that our answer is positive to the discriminant, not our overall solution, but just for that one piece, we get 2 real solutions.
What's after C?
Greater than, sorry, it kind of looks like a 7. But that is a greater than symbol after the C. If our discriminant equals 0, we have 1 real solution. So what's left? We've taken care of positives, we've taken care of 0. What else could we have happen? Okay. Less than 0. Negatives. So if we have b squared minus 4ac is less than 0, in other words, the discriminant is negative, Then we have two imaginary solutions. And we will be talking about imaginary numbers next time in more detail. Right now we just want to get used to the fact that they could exist. So you're not going to have to actually find imaginary numbers or work with them today. You're just going to have to identify, hey, we could have imaginary numbers. So let's do an example now. I want to make sure everyone has this written down though before I scroll down to the example. So we have three possibilities. So if we had a picture, it's easy to tell. We can just look at the picture. But if we don't, we're going to have to use our equation to find the discriminant. So the instructions would ask us how many and what type. When we actually use the whole quadratic formula, it's going to tell us to solve. It'll say find these solutions, not how many and what type. So when it says what type, we're using that discriminant b squared minus 4ac. And then it'll give us an equation, x squared minus 15 equals 0. Again, I want to make sure everyone has this written down before I actually start the problem. So we know what formula, because I wrote it for you. On the homework, it's not going to be written, but hopefully you could look back in your notes and see, oh, it says how many and what type. I should use b squared minus 4ac. But I have to know what a, b, and c are. So first we have to review what was a quadratic in standard form. When we were in standard form, we talked about standard form a lot when we were graphing. Then standard form looked like this. A was the number in front of x squared. So it doesn't include x squared itself. A is in front of x squared. I'll say A is in front of x squared. B is in front of x. And this is every single time, which is why I write it out. It has to be in that order. And then C has no variable. It is. Oh. Okay. So it has to be those things. It's not just about being in that order. It's about being in front of x squared. Being in front of x. Having no variable. So if we look at our equation, x squared minus 15, the reason I was so specific with what a is, what b is, what c is because x squared minus 15 is missing some stuff. It's still a quadratic because it has x squared. But what is it missing? The x is not there. The x that's not an x squared. Yes, there's an x squared, but just a plain old x. It's missing. So that's going to cause us some trouble when we try and find b. So let's first start by finding a. A isn't much trouble because we know it's the number in front of x squared. What number is in front of x squared? 1. We have the invisible 1, and there's no number written there. But b is missing. There's no x. What if it's missing? What do you think we should use when it's not there at all? There's nothing there. 0. Okay. 1 is usually one of our good invisible numbers. But if there's nothing there, there is no variable there either, we use a 0. So b is 0 because it was missing. There was nothing written there at all. So b was 0 because x was missing. Do you guys know that shorthand b/c just means because, just so we don't have to write the entire word. And then c again is easy, it's straightforward. What is c?
15.
Negative 15, we should include the negative sign. So once we've identified those, we can just plug them straight into our formula. So we said we're not using the whole quadratic formula right now because of what they asked us for. They asked us for the type, and type says use just the discriminant. We're just using b squared minus 4ac. So for every letter, I have to replace it with its corresponding number. I'm not going to write B, I'm going to replace it with a number. I'm not going to write A, I'm going to replace it with a number. I'm not going to write C, I'm going to replace it with a number. And we found what those numbers should be. So I'm going to have you guys do that, and I'm going to come around and check. Okay. So I tried to check as many people as I could. You should have gotten 0 squared. Since b was 0, that's what we said it was equal to. We put 0 first. A was 1. C was negative 15. Then we have to simplify. We still need to get just one number. So when we simplify this, we have to follow order of operations. Order of operations says parentheses first, exponents, multiply, divide, add, subtract. Now, parentheses, it means take care of what's inside the parentheses until you just have one number. All of our parentheses just have one number, so we can skip parentheses. Next, we go to exponents. So what should we do first? 0 times 0. This happens first. 0 times 0 is 0. Looks like a scary face. I just drew a... Okay? 0 times 0 is 0. Then we do multiply. We can multiply this out. When we multiply these two together first. What is negative 4 times 1? Negative 4 times negative 15 still.
60.
Positive 60. So plus 60 is 60. So the question is, are we finished? Have we answered what the question is asking us to find?
No.
Why not? I'm guessing now, since I'm asking this question in the first place. Why are we not done? Think back to the instructions. Someone read the instructions to me.
Find how many and what type of solutions.
Find how many and what type. Have we named how many and what type of solutions we have? No. So first we have to decide, 60, is that positive, 0, or negative?
Positive.
Okay, this answer is positive. So when we had a positive answer, what did that mean for our type of solution? Two real solutions. Jesus, Austin, and Taylor are all correct. 2 real solutions. Since that's what we asked for, we asked for how many and what type. We need to actually state 2 real, 1 real, or 2 imaginary. We need to actually write that information down. So what we're left with now is, what if I want you to actually find the solutions? What if I don't just want to know what type, but I want the actual values? If we look back at our picture, I'm going to scroll back up to the picture really quick. Pictures, sorry. If we look back to our pictures, I could actually find these values. On my picture, this might be negative 2. So we could say x equals negative 2 is one solution, and we'll say this is positive 2. Okay. Finding those answers is different than saying what kind. Yes, these are 2 real numbers, but what if I want these actual values? That's where we have to use the full quadratic formula. So now we're not just going to use that piece b squared minus 4ac. We're going to use the full quadratic formula. So here's our second example, where this time I'm asking you to find the solutions. It is going to take a lot of space. It's a large formula. This takes a lot of room. So when we solve, we need to know how it's set up in the first place in order to solve. Just like completing the square, this would be good setup for completing the square. We have the variables on the left, number on the right. But it is not a good setup for the quadratic formula. For the quadratic formula, we need this entire thing to be equal to 0. We want the entire thing to be equal to 0, which means I want to get rid of 10. We just need to do opposites. So what's our opposite of a positive 10?
Negative 10.
Negative 10. So we have 3p squared plus 4p minus 10 equals 10 minus 10 made 0. So we have a nice setup. Now that it's equal to 0, it's set up for us to solve. So next, if we're going to use quadratic formula, if we're going to use the negative b plus or minus square root of b squared minus 4ac all over 2a, I know it is a really long formula, we need to know what is a, what is b, what is c. So we need to identify a, b, and c again. So again, I'm going to pause for a second, and I want you guys to find A, B, and C, and I'm going to come around and see if you're doing that correctly. Okay. So A is 3, B is 4, C is negative 10. Now we can plug it into the quadratic formula. It's similar to the discriminant. It's the same idea. Quadratic formula. Now you already have the quadratic formula written down once. I'm going to write it down again so we can look at it as we do this problem. Negative b plus or minus square root of b squared minus 4ac all over 2a. Yes, it is just a long formula, unfortunately. There's a lot going on with it. So we have to replace every letter again with its corresponding number that we figured out. So we have to replace B, B again, A, C, and A again. Sometimes we use the number more than once. So we have negative from the formula, and then our first letter was B. So what corresponding number should I replace it with? 4. Plus or minus square root of b squared. We already said b is 4. Minus 4. A is 3. C is negative 10. We're replacing each letter with its corresponding value. So A was 3. We put 3 in that spot where A had been written. C was negative 10, so we put 10, negative 10 in that spot where C was written. All over 2 times A. What did we say A was? 3. So now we simplify. Today we're going to only simplify halfway. I know the formula itself is a lot of work, so we're only going to do half of the simplification. And then when we talk, we're not going to talk about quadratic formula again next time, but we will talk about it again in 2 more times, because we're going to talk about all the ways to solve a quadratic together. Then will simplify all the way. So when we simplify each section basically. I simplify here, and I simplify on the bottom. Each of those sections needs to be simplified. So the first section and the last section, those are easy simplifications. Those are no problem. If I have a negative times a positive 4, what do we get?
1, 0
Negative 1 times a positive 4.
is -4.
Negative 4. We still have plus or minus. And then on the bottom, it's just multiplication again. 2 times 3, 6. But under the square root is that discriminant. We had to go through a longer process to simplify the discriminant. So I'm going to write it over here so we can see the simplification process again. Order of operations said we had to do parentheses first, but we got to skip that. Exponents next. So what should I do first to simplify this?
The 4 times 2 or 4 squared.
4 squared, which means 4 times
16.
4,
16.
and the answer would be 16. So 4 times 4 is 16. Then we had to do our multiplication of these 3 things. So I multiplied the first 2 together. -4 times -3
It's -12.
is -12. Then we have to multiply -12 times -10,
It's 120.
and then we can just add those together. 16 plus 120 is 136.
Yeah.
So that's as far as we're going to take our simplification today. So we have actually found those 2 values where our parabola crossed the x-axis.
Wouldn't that be P though?
You are correct. I forgot we were using p's. It's not really a huge deal since we're not working with multiple variables, but it should have been p. So we have about 10 minutes to work on our assignment.